Question number 13. A rubber bug of mass m is tied by a string of length r. Kelvin swings the rubber bug in a vertical circle at a constant speed v. Part A. Draw a force diagram on the rubber bug when it is first part at the lowest point, second part at the highest point. When it is moving at the lowest point, there are two forces acting on the rubber bug. The first one is its weight mg, and the second one is the tension in the string. When it is moving at the highest point, there are again two forces acting on him. The first one is the tension in the string downward, and the next one is the weight of the rubber bug mg, which is against downward. Part B. Find in terms of r and g the minimum speed of the rubber bug v minimum at the highest point such that the string remains taut. Taut means 緊. In order for the string remains taut, which means that the tension of the string must be greater than 0 or equal to 0. When t is equal to 0, the string will start loosen, 開始鬆啦. Consider the force diagram when the bug is at the highest point P. By F equal to ma, centrifugal force acting on the bug at the highest point equal to its mass times centrifugal acceleration at this point P. Centrifugal force is the resultant force at P. The resultant force is T plus mg towards the center, equal to m times AC. AC is equal to v squared over r. Therefore, the tension in the string equal to m times v squared over r minus g. In order for the tension to be greater than 0 or equal to 0, we have v squared over r minus g must be greater than or equal to 0. Therefore, v squared must be greater than or equal to rg, implies the speed at the highest point must be larger than or equal to square root of rg. Therefore, the minimum speed of the rubber bug should be equal to square root rg. Question number 14. A jet plane is moving in a vertical circle of radius 3 km at a constant speed of 250 meters per second. Part A. Find the centrifugal force Fc acting on the pilot of mass 72 kg when the jet plane is at the highest and lowest position. At the highest position P, the centrifugal force acting on the pilot is pointing towards the center of the circle. Fc at P equal to m v squared over r, which is equal to 72 times the square of 250 meter per second over 3 kilometer equal to 3 times 10 to the power 3 meter. The centrifugal force acting on the pilot at the highest point P would be equal to 1,500 Newton. Similarly, when the jet plane is at the lowest point Q, the centrifugal force acting on the pilot is still pointing towards the center, which is upward. Fc, by definition, Fc equal to mac, which equal to mv squared over r. Since the speed is constant and the radius is constant, therefore we got the same value of centrifugal force acting on the pilot at the lowest point, which is again equal to 1,500 Newton. Part B. Using the result of A, find the force acting on the pilot by the seat, which is the reaction force R, at the above positions. At the highest point P, the force acting on the pilot are the weight of him and the reaction force acting on him by the seat R, which are both downward. Therefore, Fc equal to R plus mg, which is equal to mv squared over r, implying reaction force acting on the pilot at the P equal to mv squared over r minus mg, which is equal to 1,500 minus 72 times 9.81, which is equal to 794 Newton. When the jet plane is at the lowest point Q, the force acting on the pilot are the weight mg downward and the reaction force acting on him by the seat R, which is upward, or R pi, which is upward. At Q, the centrifugal force acting on the pilot is equal to reaction force R pi minus its weight mg, which is towards the center, equal to mac. Therefore, R pi equal to mac plus mg, which is equal to 1,500 plus 72 times 9.81, which is equal to 2,206 Newton, which is heavier than his weight. Question number 15. A small cone of mass 50 grams is put on the edge of a disc of radius 20 cm. When the disc rotates about the center O at a speed of 0.3 revolution per second, the cone remains on the disc without slipping. 佢唔會跣走。Part A. Find the centrifugal force exerted on the cone, Fc. State the origin of this force. By definition, the centrifugal force on the cone, Fc, is equal to its mass times centrifugal acceleration, which is equal to m times v squared over r, or equal to m times omega squared r. Since omega equal to 0.3 times 2 pi over 1, which is equal to 0.6 pi radian per second. Therefore, we have centrifugal force on the cone equal to 0.05 times 0.6 pi square of this one times the radius, which is 0.2 meter, and the centrifugal force will be equal to 0.0355 Newton. Part B. If the speed of the disc increases steadily, the cone will eventually slip on the disc. Explain why this happens. Since centrifugal force equal to m omega square r, if the angular speed increases, then the centrifugal force on the cone must also increase. Since the centrifugal force is provided by the frictional force acting on the cone by the disc, and friction has its limiting value, which means we have a maximum friction acting on the cone. If the angular speed is too large, such that the centrifugal force exceeds the limiting friction, then the cone will slip on the disc.